Preparation of Dimethylaminobenzaldehyde from Organic Syntheses by various contributing authors. For the LibriVox Coffee Break Collection number 11, Science. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Son of the Exiles. Dimethylaminobenzaldehyde from Organic Syntheses. 1. Procedure. In a 3-litre round bottom flask fitted with a mechanical stirrer, 150 grams of technical dimethylaniline are dissolved in 750 cc of diluted hydrochloric acid, 1 part concentrated acid to 1 part water. This solution is now cooled to 0 degrees, and a solution, previously cooled to 0 degrees, of 90 grams of technical sodium nitrite in 150 cc of water is added through a separatory funnel. During the addition of the nitrite solution, mechanical stirring should be employed and the flask cooled well with ice and salt. The addition is made at such a rate, 30 to 40 minutes for the entire addition, that the temperature does not rise above 5 degrees. The precipitate of nitroso-dimethylaniline hydrochloride is filtered off with suction, then washed with about 300 cc of diluted hydrochloric acid, 1 to 1. In a 2-litre beaker, 180 grams of technical dimethylaniline, 125 cc of formaldehyde, technical 40%, and 300 cc of concentrated hydrochloric acid are mixed and heated for 10 minutes on a steam bath. The mixture is now placed in a hood and the nitroso-dimethylaniline added all at once, or as rapidly as possible. The beaker is then covered with a watch glass. A vigorous reaction soon occurs and is complete in about 5 minutes. The resulting solution is transferred to a 5-litre flask and diluted to 4 litres. Stirring is started and a 25% solution of sodium hydroxide is added until the red colour disappears. About 650 cc are required. The yellow benzalidine compound separates, is filtered with suction, and washed with water. The moist precipitate is transferred to a 4-litre glass jar, covered with 1000 cc of 50% acetic acid and 250 cc of formaldehyde, and stirred until 20 minutes after the benzalidine compound has gone into solution. While the mixture is being stirred vigorously to prevent lumping of the precipitate, 400 cc of water and 200 grams of cracked ice are added during the course of 5 minutes. The dimethylaminobenzaldehyde generally separates gradually in 15 to 20 minutes, but in some cases does not. If the precipitate does not form, the solution is placed in a refrigerator for a few hours or overnight. The mixture is filtered with suction and washed at least 10 times with 300 cc of water. The precipitate is sucked as dry as possible for 15 to 30 minutes. The slightly moist aldehyde is distilled under diminished pressure from an oil bath by means of a 1-litre Claison flask. A small amount of water comes over first, then the thermometer rises rapidly to the boiling point of the aldehyde, 180 degrees 22 millimeters. In changing receivers between the water fraction and the aldehyde, care should be taken to keep the sidearm of the distilling flask warm, otherwise on starting the distillation again the aldehyde will solidify in the sidearm and cause trouble. It is advisable not to collect the very last portion of the distillate with the main portion, as the former is frequently quite red. This is best added to crude material from another run. The main distillate is dissolved in 100 cc of alcohol in a 2-litre beaker, then 1000 cc of water are gradually added with vigorous mechanical stirring to prevent lumping. The aldehyde separates and is filtered with suction. The product, when dry, weighs 125 to 130 grams, 56 to 59% of the theoretical result, and melts at 73 degrees. The aldehyde prepared in this way is in the form of small granular crystals, which vary in different runs from a flesh colour to a lemon yellow. For practically all purposes, this slightly coloured product is entirely satisfactory and is essentially pure, as can be judged by the melting point. For reagent purposes, it is desirable to remove the colour completely, particularly since the product obtained as just described has a tendency to take on a reddish tinge on exposure to light. Further purification can be accomplished by dissolving the aldehyde, it dissolves slowly, in dilute hydrochloric acid, 1 part of concentrated acid, specific gravity 1.19, to 6 parts of water, 125 grams of aldehyde requiring 700 cc of the acid. The solution is placed in a jar and diluted with half its volume of water, and dilute sodium hydroxide solution, 15 to 20%, is added slowly with mechanical stirring. At the beginning, the aldehyde comes down slightly coloured. After about 10 to 30 grams are precipitated, however, the product appears white. This point can be readily seen. The first precipitate is filtered off and added to the next run of crude material, or fractionally precipitated again from hydrochloric acid. The rest of the aldehyde is now precipitated by means of more sodium hydroxide solution and comes down almost white. At the very end of the neutralization, particularly if the original product was quite yellow, the last 4 to 5 grams of aldehyde should be precipitated separately, as they are inclined to be slightly coloured. If too much alkali is added towards the end of the neutralization, a brown colour appears, but the addition of a little hydrochloric acid will destroy this colour. The main portion of the precipitate is filtered and dried. It weighs 95 to 100 grams, melting point 73 degrees. The succeeding runs yield 115 to 128 grams of the finished product, on account of the extra crude material obtained from the distillation and reprecipitation of the previous run. 2. Notes. The aldehyde that is obtained without reprecipitation gradually takes on a pinkish tinge on exposure to light. After the reprecipitation, however, this characteristic disappears. Thorough washing of the crude aldehyde is particularly desirable, as it removes a reddish impurity which tends to distill over and colour the product lemon yellow or sometimes even brownish yellow. When such a brownish product is obtained, it is quite necessary to make a second precipitation, as well as to observe the directions mentioned in the purification of the crude aldehyde, namely, to precipitate the first few grams and the last few grams of the aldehyde separately. The precaution of rejecting the first and last portions of the precipitate is unnecessary in the reprecipitation. In the reprecipitation of a deeply coloured product, the portion of aldehyde at the end may be even purplish in colour, and particular care must be taken to keep this separate. Vigorous mechanical stirring must be employed during the precipitation of the crude aldehyde, as otherwise large lumps are formed which make washing difficult. A previous investigator has mentioned that the crude product must be dried before distilling. This, however, is unnecessary. If the aldehyde is dried before distilling, it is possible to use a 500 cc distilling flask instead of a 1 litre one. In purifying the aldehyde by dissolving in acid and reprecipitating, it is essential not to use stronger acid than that specified, 1 to 6, as stronger acid causes a deepening of the colour of the solution. If the concentrated acid, which is to be diluted and used in this procedure, does not have a specific gravity of 1.19, it will be necessary to add the equivalent amount of weaker acid in order to dissolve the para-dimethylaminobenzaldehyde. In purifying the aldehyde, sodium carbonate may be used in place of sodium hydroxide for precipitation, but it causes much foaming. When the apparatus for distilling, etc., is all set up, a run such as described above requires about 5 to 6 hours for completion. 3. Other methods of preparation. Para-dimethylaminobenzaldehyde has been made by the condensation of chloral with dimethylanilene and subsequent hydrolysis, by the hydrolysis of tetramethyldiaminobenzhydrol with acetic acid, by the condensation of dimethylanilene, formaldehyde, and metasulfoparatolulyl hydroxyl amine followed by hydrolysis. By the electrolytic reduction of a mixture of sodium nitrobenzene sulfonate, dimethylanilene, and formaldehyde and subsequent hydrolysis. By the reduction of a mixture of dimethylanilene, formaldehyde, and sodium nitrobenzene sulfonate with iron and hydrochloric acid followed by hydrolysis. By the condensation of alloxan with dimethylanilene followed by hydrolysis. By the condensation of dimethylanilene, formaldehyde, and sodium paratoluidine sulfonate in the presence of hydrochloric acid and potassium dichromate followed by hydrolysis. The most satisfactory method, however, is the condensation of dimethylanilene, formaldehyde, and nitrosodimethylanilene followed by hydrolysis, a method which was first described by E. Nölting and later perfected in detail by L. Baumann. End of Para-dimethylaminobenzaldehyde by various contributing authors. Recording by Son of the Exiles.